Hello, Algebra 1 students. This is lesson 57. Our objective is how do you find the least common multiple? We abbreviate that with LCM. The L stands for least, or the smallest. Common is they both or all of them have it. And then a multiple, just think about like 5, 10, 15, 20, 25, 30, etc. Those are multiples whenever you multiply a number by 3, 4, 5, 10, 20, etc., etc. So we're trying to find one of them that all of them have, that's the smallest, but that they all have. Okay? So you can, if you want to, on some of these, you just start listing multiples, 24, 48, etc., etc., and keep going until you find one. Okay? And that is one method that works whenever you're working with just integers like this or like this. But it can be really long. As you'll see, some of these numbers are actually pretty large. So there's kind of an easier way to do that, and that is to write each of them in a prime factorization. I'll show you how to do that in just a moment. And then step 2 is to use those prime factorizations to then make the least common multiple, or to help you find that. So notice here I've just done some factor trees where I said 24 is 2 times 12, 12 is 6 times 2, 6 is 2 times 3. So what we can do here is we can write this in as just being 2 times 2 times 2 times 3. So that's written as its prime factorization. Now also, if you wanted to, you could say that's 2 cubed times 3. And then 36, I did the same thing. This is going to be 2 squared times 3 squared. Okay? So think about, if I want to have a multiple of 24, I'm going to have this in there somehow. Okay? I'm going to have a 2 cubed and a 3, and if there's more numbers than that, then that's just fine. Okay? I can have, if I want to, I could have 27 2s, it's fine, as long as I have at least 3 of them, and at least 1 3, then I can use those to make a 24. So then I'm going to go and just write those over here for my LCM. I'm going to say my LCM is equal to 2 cubed. I'm going to write it like this, because that has 24. Now, for my 36, notice I need to have 2 2s, and I need to have 2 3s. So notice I already have 2 2s there, and I already have 1 3, so all I have to do is add one more 3 in there. So notice these ones here, if I multiply them together, would get me 12. Would give me that 24. And then if I multiply it by 3, then that means it's going to come out to be a multiple of 24. Right? Multiple, by multiplying it by number. And if I multiply these ones together, I'm going to get 36. And if I multiply it by 2, then it's going to come out to be a multiple of 36. So then all I need to do is just simply multiply all 5 of these numbers together, and I'll get the LCM. So that means the LCM is equal to 72. Alright, so notice we just found the LCM of 2 different numbers. But you can actually do this for 3, 4, 5, 27, however many numbers you want. It just tends to make that LCM get a whole lot larger. Okay, so same idea here. I have taken each of these 3 numbers and written as prime factorization. 11 is a prime number, so it's just equal to 11. This 12 is going to be 2 squared times 3. And the 18 is going to be 2 times 3 squared. So that means my least common multiple is going to be, well, for the 11, I'm going to have 11 in there. To have the 12, I'm going to need to have 2 2s and a 3. And to have the 18, I need to have 1 2, which I already have, and 2 3s, I have one of them, but I need one more. So again, notice here's the 12. This part right here is the 18. And then this part right here is the 11. So So just need to multiply all of those numbers together, and my LCM will come out to be 396. Alright, now least common multiples are not just of integers, they can also be of monomials. And so really we're going to do the exact same thing we did before. This one here is just 2 times 5 times a times a times a, because it's a cubed, times c times c times c times c. This one here is going to be 3 times 5 times a times a times a times c times c times c. So that means my least common multiple, well, to get the 10, I need to have a 2 and a 5, and here I have to have a 3 and a 5. So I'm going to have a 2 times 3 times 5, right? This one and this one together gives me the 10. This one together gives me the 15. Then I need to have 3 a's for this one and 3 a's for that one. So that's easy. A times a times a. This one I need to have 4 c's. This one I need to have 3. So that means if I have 4, I also have the 3. So b times 1, 2, 3, 4 c's. Simplifying that down, it's going to give me 30 a cubed c to the 4th. So you can kind of see here, this was a c to the 4th, that was a c cubed, so I just picked the one with the larger. And since these two are both the same, I just went with that. And then kind of the same idea there with the coefficient as we did on the previous slide. Let's try another one. This one has 3. So this one here is going to be 2 times 3 to get that 6 times p times p times s times s. This one is going to be 2 times m times m times s times s. This one's going to be 2 times 2 times 2, because that's 8, times m times p, times m times p, because that's a 3 up there. So let's look at the coefficients here. I need to have a 2 and a 3 for this one. I need to have a 2. I need to have 3 2's for that one. So I'm going to go and write 2 of them here. 2 times 2 times 2. That gets this one and that one and this 2. But I also still need that 3. So I'm going to say times 3. I need 2 p's. And there's 1 p. So I can just go ahead and put in 2 of them. And to have 2 s's, that has 2 s's, that doesn't have any s's, so I need 2 s's. And then this one has 2 m's, this one has 3 m's, so I'm going to pick the one that has more. So m times m times m. Simplifying that down, you get 24 p squared s squared m cubed. Again, we looked at, there's a p squared and just a p to the first power, so pick the higher one. S squared, no s's, so s squared. M cubed, so pick the one with the higher one. And do the same idea there with the first part. Alright, now we can also do this whenever we have like binomials. And so remember, the that multiple means I'm going to multiply this by something to get the other one. So I'm not trying to add or subtract, it has to be multiplication. So this one, I need to see if there's anything I can factor out of it. Well, in fact, there's not anything I can factor out of it. So look at this one, is there anything I can factor out of that one? No. So think about, like, if you had 2 prime numbers, like if you want to find the LCM of 2 and say 11, which are both prime numbers, you have to just multiply those two together. Say 2 times 11, and then you get 22. That's the LCM of those two numbers because they don't have any common factors. Same idea here. They don't have any common factors, so the LCM is just going to be the product. 3x plus 1 times 2x plus 9. So this one's in there, and this one's in there. And there's some multiple of each of them. So that's the LCM of this one, of those two. Now in part B here, I'm noticing that there is something I can factor out of these terms. So both this one and this one have a 7 and an x in common. So I can say 7x, and whenever I take a 7x out of this, the only thing left over is an x. And the only thing left over from this is going to be a 3. Over here, I'm noticing I can pull out a 6 out of both of those, so I can put a 6 on the outside. This is going to be an x plus 3. So now we're looking for things they have in common. Look, they both have that x plus 3. So my LCM is going to have an x plus 3 in them. I'm going to need to have a 6 on the outside. That's just 2 times 3. 7 is prime, like, this was a 9, like a 3 times 3. I do the same thing as I did before, but I don't. So I'm going to have times 6 and times 7. Remember, I also have that x right there, so I'm going to multiply it by the x. So simplifying that down, you get 42x times x plus 3. Alright, let's try one more of those, hopefully make that sink in a little more. I'm looking for things that these two have in common, and previously whenever we talked about this, we could write these numbers as prime factorization in their prime factorization, if that helps us. I'll figure that out. So it'd be 2 times 3, that's the 6, and then multiply it by 10, so it'd be times 5 and a 2. Times x times x times x. Plus that 24 is 12 times 2. 12 is 4 times x. So now I'm looking for things they have in common. They have 2 2's in common and a 3. So 2 times 3, and also an x on the outside. So 2, 2, and a 3, and an x. 2, 2, and a 3, and an x. So that'd be 5x squared plus 2. If I do this one here, that is 15 times 3, 3 and 5, x, plus 18 is 9 times 2, so 2 times 3 times 3 times x. So notice they have 2 3's in common and 2 x's in common. What's left over is a 5x squared, right? 2 x's plus 2. Okay? A little bit of work, but we can still get there. So that means my LCM, notice they both have this piece in common. So I'm going to put that in there, 5x squared plus 2. Outside I have 2 x's and 1 x, so that means I'm going to need 2 x's. So it has 2 3's. So I got that one, but so I just need 2 2's now. Simplifying that all down, let's see, 2 times 2 times 3 times 3, that's 4 times 9, 36. X times x is going to be x squared, and then that 5x squared plus 2. So that's the least common multiple of those two binomials. Feel free to back this up and watch it again. It doesn't mean you're stupid, it means that you're trying to learn something. So feel free to do that, and then if you have further questions, ask me and I'll try to help you out with that. Your homework is there on page 372. You can do the lesson practice. All the 57s. You don't have to do the 56s because we skipped that lesson. And then 7 more of your choice.